Okay, we start our class today with the session of Umul Kitab Al-Fatihah. Okay, so today we continue with our polymer part. So the polymer number 4. So in the previous class we learned what? We learned about this resin, about the mechanical characteristic of the polymer, especially in terms of temperature. We divide the polymer into two: thermoplastic or thermoset. Thermoplastic is a polymer that you can melt and remold again and again, whereas thermoset, once you mold the thing, then you cannot melt again. When you hit the thermoset, it goes up to the degradation point and it will doesn't melt lah. It's not doesn't melt, it means it will degrade. You put heat and then it will degrade. Rather than melting, it will degrade. So that's why you cannot reuse thermoset. So if you have something like the rubber tire, the car tire, you cannot sort of like bring this, for example, this car tire. You have this car tire, the car tire. Once, for example, when the tire is out of his lifespan, meaning that tire botak, when you use a long for few years, then the tire will not be usable anymore. Then you need to change the tire. So what happened to the old tire? Normally the way how they recycle, the word recycle doesn't mean you melt and then you make a new thing. No, that's one way to recycle. The word recycle, one way to think about the word recycle is that you have something, for example, you have a bottle, and then you melt, and then you make a new bottle again. So that's one way to view about what is recycle. But another way to view about recycle is that this thing, you have like a tire. Okay, tire is thermoset, so you cannot melt. So what people do is that either they dump into this whatever pit. Normally they don't do that because it will waste a lot of landfill area. Sometimes they just dump it like this. You just let me open the this thing. I need to open this thing. Okay, let me open this thing. Tire dump landfill. So sometimes they just dump something like this, whatever. So you can see there are a lot of tire on the landfill. So it will landfill. They have its own use. For example, all the what we call the rubbish that you throw away from your home, from your kitchen, and then the dumpster take it and then they put in the landfill, and then they bury it under the soil. So if the thing is what we call biodegradable, it's okay, it will decompose inside the soil. But if you have something like plastic like this, it will take a long time, meaning that million years in order for them to decompose, to degrade. Okay, it doesn't mean when you put plastic under the soil, it doesn't mean the plastic will forever be there. No, it will eventually be broken, but it will take a long time, meaning that longer than the span of the human life. So because of that, we say it is non-biodegradable, non-recycle. Even though, because if you think about it, whatever you put on the soil, over like a million years, it will sort of like condense with the pressure and also pressure of the crust of the earth, and then eventually the thing will become oil and so on. So, but because that thing happened too long, it takes long time to happen, then we classify that as non-biodegradable, non-recyclable. Okay. So this is what happened if you just this tire, you cannot remelt and again. So you just dump into this landfill, and because tire is big, it will take a lot of space. So that's the problem. So what people do is that they take this tire, the way how they recycle it, they sort of like crush this tire and they make this like what we call the pavement grubber. I don't remember what the name. Pavement grub or what? What is that? Tu apa? Ini cacing. Apa? Pavement rubber, pavement Rubber.
Gravel ke?
Is it tar?
Not tar. Tar is not rubber. Tar lah. Tar bukan rubber. Ni. Ha ni. Ni. Rubber pavement. You see this thing? This is basically made from let me make this here. Let me make here. So this thing mostly is made from this what we call the old tire that is shredded. Okay, so the one that in the playground and so on, even the athletic balapan tu, the track and running, some of them they are made from this recycled rubber lah. Okay, so but mostly when you go to the park, not the tar one, but this rubber paving they call it. So this thing, okay, it's not the tar one. The tar is the tar lah. The tar is basically you have this small not rubber but small stones, and then they put the tar on top of it. Okay, so that's how they do it. Recycle rubber. So this the thing, the image of recycle rubber. So they don't melt it and make a new. They need to sort of like do something else. So this also considered as what we call recycle lah. We can call it recycle. Okay, like coming back to this. So that's what happened to this thermoset lah. So thermoset you cannot remelt and remold again. You can recycle, but the way how to recycle is maybe shredded and then make the pavement apa nama dia? Dia term pavement what? I don't remember, but pavement rubber lah. You know lah, playground, in the playground. I think you maybe playground. Okay. So that's the thing. And then we learn about the epoxy is one type of the another type of the thermoset. Okay, we see about this image. Let me take this thing, go to here, and then I take this thing, make this thing. Okay, so we see that epoxy before, and the one that I did last time. Okay, so if you are around, I think you can hear it, right? Oh, now I don't close the. Normally I close the what we call the fan, because if not the recording will be, when you hear the recording it will be like sounds like that, because my room doesn't have aircon. I don't know why. Anyway, so here this is the epoxy that we did before. If you look, if you can hear it, it seems like very hard lah. This thing very hard lah. It's very hard. But if you look at the side of it, if you can touch it, it seems a little bit sticky. Because why? Because when we try to mix the epoxy before, we mix in the middle. But on the side, they might be, it's not might be, it is, what happened is that there are not enough hardener and the resin mixed together. So this side is not cured. Not cured meaning that it will not be hardened. So if you are here, if you are in physical class, I will ask you to touch this thing and you will see there are some stickiness there, still stickiness. Remember, this epoxy is not water, meaning that over time they will not be evaporated. It will be there. It's like oil you put somewhere, you put on the table, it will be there oil forever lah. But if you have water, it's different. Water you can have because the boiling the air, you can evaporate lah, the water can evaporate, but this is still sticky lah, still sticky. And this is what we call from our super glue. The super glue, what is the super glue? So the super glue, I need to make this thing here. Let me put here first. Okay, epoxy. Okay, so this super glue is basically made from acrylic. Okay, cyanoacrylic. Okay, so that is the what we call the content of the super glue itself. So it's just need one part, and because the other part is the moisture kick the reaction happen, so the curing, the cross linking happen when it's meet the moisture. So that's why you get this, everything regardless the side or the middle, is all the what we call is all cured. So even I touch the side, it's still hard because they use the moisture in the air, and everywhere there are moisture. But here they don't rely on moisture, but they rely on the hardener and resin must mix in the right proportion. Okay, if you don't mix in the right proportion, it will not harden. Okay, and then we learn about so that's how you initiate a cross-link chemical reaction, moisture, heat. You can also UV, also you can. And then we talk about the silicone. Okay, the silicone, you need to have this. This the main thing about the silicone. You have the what we call the backbone, silicon, oxygen, and so on. And we mentioned that the silicone is not the same as silicon. Okay, with E is a polymer. Without E is the element, the one that you use for the semiconductor. That is silicon. And then we learn about rubber. Okay, rubber we just we have talked about this rubber. Okay, the rubber is not silicon because I put 3 silicon rubber. This I afraid that you will be sort of like confused. Let me put this thing like this lah. Rubber. If not, this different color. If not, you think that rubber is under silicon. Rubber is not silicon. Rubber is rubber lah. Silicon is silicon. But the reason why I do this is just to combine them together, because the rubber is over there, is up there, is too far. Just to combine the silicon and rubber together to show that these two things is under the same class of elastomer, something that have this high deformation. You have something elastic, and then when you release the elastic, it will return to the normal again. So we learn polymer, elastomer, thermoplastic, thermoset, and at the end we talk about this pressure, high pressure, low pressure, and so on. And I tell you in the previous class, it seems like confusing why we learn this thing, right? Why we learn this pressure, this thing boil, whatever, this thing either gas law, whatever, this thing. What is the use of learning this in your what we call in this material class? Okay, now I want to talk about this. How to connect this thing with the polymer class. Box ini. Okay, it's okay. So let me make it small. So this I will bring here. I will take this. Okay, I just make it there. So I just use whatever available there. And then, okay, normally when you have something like this, you have something like this, the epoxy. So this under the what we call. Let me put here first. Okay, let me put this epoxy, under epoxy again. The epoxy. When you do, it's fine to have something in the tube like this. Okay, in the tube like this. But when you want to do something big, okay, when let's say, because epoxy doesn't, the use epoxy is widespread. For example, you want to attach the wing of the aeroplane, they use also epoxy. Okay, they use epoxy also. They don't really use the screw only. They use epoxy also to attach the wing of the what we call, the wing of the ni lah, the aeroplane. And most part of the aeroplane is attached using epoxy. Okay, not with the thing. So you need a lot of epoxy. And then if you have this thing, then it's very difficult lah. It's small, right? So and in fact, when you learn later on about the composite, okay, most of the composite, when they want to do carbon fiber composite, you heard about carbon fiber composite, CFRP. Okay, this is carbon fiber reinforced composite. So basically, what it does, this you have this part, the carbon fiber part. So you have this, let's say the carbon fiber part is like this, and then this, how they sort of like combine them. This carbon fiber is just like a strand of a fiber. So how they combine them together is that they use this epoxy. So for example, this thing, the green one is epoxy, the black one is carbon fiber. So basically they impregnate. Okay, the term is impregnate. They impregnate epoxy, impregnate carbon fiber with epoxy. Okay, what does it mean is that you have imagine your shirt. Imagine your shirt. Your shirt, if you look under the microscope, you will see the hole, right? So the carbon fiber, you can also make like your shirt. Okay, and then when you do that, they are like tiny hole. So Impregnate meaning that you flow the epoxy through the hole like that, meaning that you put inside the hole and so on, so that it become one. Okay, so that's how people make a carbon fiber reinforced composite. So the P here is basically polymer, carbon fiber reinforced polymer. Okay, polymer. So that's the polymer they use is epoxy. Okay, this we will learn in the future class lah when we talk about the composite. But just to show you that if you want to impregnate carbon fiber with the epoxy, you cannot use this, because this is difficult lah. It's difficult to sort of like do this and that thing. So normally when you talk about epoxy, when people talk epoxy, they talk about something like this, about something like this in the liquid form. I mean, they sell in liquid form. This also liquid, but it's like more viscous lah. More viscous. It's easy for like a quick DIY thing to sort of like to secure something and so on. But normally when people talk epoxy, they talk about this liquid thing. And the reason why this what we learned before, this thing is important. This thing, the pressure thing is important, is because when you have two things like this, and when you combine them together, this thing is not like water. It's not water. It's viscous, like honey. So when you combine them together, you mix them, because you need to mix them. When you mix them together, you sort of like bring the air from outside inside the mixture. And when that happens, the bubble will be formed. The bubble will be trapped inside the mixture. So just to let you see, so let me show this. So imagine that you want to mix them together. You want to mix them together, and this what we call the epoxy. They are one big, one small. So this is the resin. The big one is the resin, and the small one is the hardener. So same like the epoxy that we learned before, they must be two part. Okay, when they combine, then they will be hardened. So this is the resin. This is the hardener. This is resin, and this this epoxy is 3:1, meaning that they have their ratio. The one that we heard before, the one that in the tube, normally you have this thing and you have this thing. Normally the ratio is 1:1. The resin, this the hardener, and this the resin. Normally when the what we call the ratio is more or less the same, the curing time is fast. Okay, and they also also you can find this and a little bit bigger like this. So this is this is one. This is 1, 2. Salah lah ni. Saya buat ni resin. Ni saya buat hijau resin. The green one is resin. The blue one is hardener. Okay. So you see, they are also 1, 2. Okay. Meaning that you need 2 part of the resin mixed with the 1 part of the hardener to make it cure. I mean cure lah. So normally this 1, 2 part you can normally find it for the CFRP. When you want to make the carbon fiber reinforced composite, normally they use 1, 2 part, one hardener and 2 resin ratio. Okay, and also this one, the one that you see in front of me, is basically 1:3. This is basically 1:3. So I have this thing. And then the what we call the resin is bigger. So this is basically 1:3 hardener. And normally you find this normally 1:3 is much cheaper lah. It's cheaper because you need a little hardener only, the cross linker. So normally this when you buy for the art supply, they use this 1:3 lah. So this normally they use for the art supply, art resin, whatever lah. Not necessarily, but typically this is cheaper. When you have this is pricier lah, because you need more hardener and resin, more hardener compared to this 1:3. Okay, let me put this no need lah. Okay, so if let's say you put two things that is viscous together, because this also the way how material combine. So let's say this thing, I need to put 2 and this 3, and this is 1 hardener. So in order to put it together, you need to measure, weigh it very accurately. You cannot just put by looking only, because this, if you make the ratio slightly less or slightly higher than what they recommend, then your end result will not be as strong as intended. Okay, if let's say you put this 2 instead of 3, 2 part plus 1 instead of 3 plus 1, then you get your end result will be not so so strong. So in order to measure this, in order to this thing, normally we don't use volume. We don't use the measuring cup or whatever, because this the ratio is by weight. It's not by volume. This thing, all this ratio, the one that you see 1 1 1 2 1 3 for the epoxy, is mostly by weight, not by volume. And weight and volume is two different things. Okay, water is okay lah. Water, 1 kg of water equivalent to 1 liter of water. So because the density of water is 1. Okay, so if you have water, 1 kg of water equal to 1 liter, because the density of water is basically 1. Oh, that's not besar, but I think you can see lah. So the density of water is 1. But if you have something like oil, it's not the same. 1 kg of oil not necessarily equivalent to 1 liter. If you have ethanol, 1 kg of ethanol is not necessarily 1 liter. So weight and volume cannot not sort of like similar. Except for water. Water is because of the density is 1, then it's okay lah. Okay, so for this, you need to measure by weight. So you need to have, okay, so this thing. So you need to have this, what we call the weighing balance. So let me make it bigger a little bit. Let me, properties. Wait, I want to zoom. Copy video. Okay. Okay, so let me a little bit zoom there. Okay. I don't know lah where you can see. So I need auto open this thing. Okay. So for example, because I need to use 3 part of this, so I just measure 30 lah. 30. So I put there. Okay, so I put there, and then I tear. Wait a minute. Okay, so I will put 30 ml for this, and then 10 ml for this. So you get this 3:1 ratio. So you need to make sure when you do this resin mixing, you need to make sure it's by weight, not by what we call by volume. So this 30, we put 30. Okay, you have 30 there. Okay, most important, you need to be accurate. So that's 30, right? So that's 30. Because if not, then the reaction will not, I mean, they will be leftover hardener to be cross-linked, or leftover resin to be cross-linked if you not make it accurate. So now I want to put 10 ml lah. So meaning that 30 plus 10, 40 lah. So I put 10 until 40. Okay, so that's 30. It's difficult to do this thing while teaching, but it's okay. So that is 40. So now when you mix this resin together, you can only initiate the cross-link, because now when you put a layer on top of another, because the first layer we put is the resin, right? We put this first, and then next we put this hardener. So now it's basically the hardener on top of the resin. So when you have this thing together, the area of contact between resin and hardener is just on this layer, on this surface layer mana ni. So when you put just like that, it just, for example, this is your resin, you put 3 before, right? 3, and then you put the hardener, because these two things now it's just like this, it's just like this. So you have this area of contact here is just to minimize lah the contact between the resin and the hardener is just that what we call the surface. So you need to mix them to sort of like all the resin and hardener contact with each other. So normally people use this what we call the wooden spoon or whatever lah. So you can just make that like that. So I just make like this. So sometimes you just make a very normally you make slowly lah. But I just want to show you that if you make a very sort of like very hard, very what we call very vigorous like this, because sometimes if you have a small volume, it's okay, you can just slowly mix like that. When you mix slowly, then the possibility for the air to be trapped inside the mixture is lesser lah. But if you make very vigorously like this, you will see then, let me make this there lah, we're done with this. So what you can see, let me zoom a little, zoom, go here. Okay, you can see that they are, I don't know whether you can see, but hopefully you can see. So if you make like that, this is not very viscous lah. So actually even if you mix vigorously like this, it's still okay. But there are some thing that is very viscous that you cannot do this, because some silicone also work like this. You need to sort of like, if you use a liquid silicone, later we will talk about the liquid silicone, you also need to mix like this. But liquid silicone is more viscous than the epoxy here. Even here, if you look there are a lot of bubble. I don't know whether you can see inside or not, but hopefully there's a thing about this using camera, you cannot really appreciate the thing, because there are bubble inside, the small bubble inside. We don't care about the bubble on the surface, because bubble on the surface will be pop like that. But bubble on the inside, now if you have something like this and then you want to cast it, okay, the term is cast. Let's say you mix, let's say this thing you mix, okay. So what I teach you now is basically the process to make epoxy or whatever. So normally you mix. Okay, so when you mix vigorous, then possibility of bubble will be trapped. Bubble trap. So at the end of the day, why you mix this thing is that let me make it bottom, is you want to cast. You want to cast somewhere. You want to cast. Okay. Let's say I want to cast on this. Let's say I want to cast on this silicone mold. Okay, this is made from the silicone. Okay, because it's non-stick. So I want to cast whatever I do in here. But now, if I cast now, what happened is that this bubble will keep trapped. Okay, so let me put here. So at the end of the day, if I cast here, let me put this. If I cast here, what happened if I put in the mold? Let's say this is silicone mold, and then I put the blue one is the what we call the resin. At the end, after it's cured, you will see inside this resin there are like bubble there. Bubble inside, bubble trap. Because remember, if you have water, and then you sort of like this water, and then you shake like this, yes, they are bubble. But because water is not viscous, the bubble, remember, bubble is what? Bubble is air. So air is less dense than the water. Okay, the density of the air is less dense. So the air will go up. And then on the surface, it will pop. Okay, so for the water or whatever, that's okay. You stir lah macam mana pun. You stir what we call the coffee ke, or chocolate ke, or your tea ke. It doesn't matter, because mostly it's water, and water is not viscous. But if you have like honey or whatever and you stir, then you will see the bubble like what we see now. So when you put the thing, when you have the mix and then you pour into the cast, whatever cast you do, it will, when it's cured, some bubble, so this bubble, some bubble doesn't have time to rise. Okay, bubble is air, right? Doesn't have time to rise because it's cured first before the bubble reach the top. So the bubble will be trapped. So this is what we call the trap bubble. So when you have this material with the trap bubble, so this bubble, let's say you make a sort of like what we call, let's say panel. Let's say you have this panel, and then you have the bubble inside, the micro bubble. Maybe the bubble is not big, but micro bubble. This micro bubble, for example, let's say you want to do this. You want to test the strength of this panel. Okay, let's say this is the panel. You want to test this strength, the strength of this panel. If you pull like this, if you pull like this, and this like this bubble will initiate. This will become part. The crack will initiate here lah. It will easily initiate at the bubble part, because the bubble mean that when you have bubble, the air mean that you have less volume, less what we call less material. When you have less material, then it become less strong lah, because the material is the one that you want to use. But if you have less material because of bubble, then this not only it will become the point of the crack propagation, it also give the overall structure sort of like weak what we call weak properties. That's why when you see people make a building, they will bancuh cement, right? You see they have this concrete or whatever cement, they have this bancuhan, apa nama dia tu? Cement bancuh, what they call concrete mixer. That's why they use this. That's why they use this stuff, right? They need to make sure it's the same idea with the epoxy lah, but it's the different. They don't use this two part, but the idea for the concrete is composite. We will talk about the concrete later on, but basically the concrete you need to mix also, because if you don't mix properly, then the reaction will not kick fully, and also you will entrap the water inside. So if let's say the mixer, because they in fact they are like the field of study about concrete mixing. They are the entire study of the concrete mixing itself, to show that how important the mixing when you are making the material, because you learn about material and also you learn about the chemistry. If you don't mix properly, then a lot of things will happen. Most of the reason why the concrete is not you see the crack whatever, because the proportion, the mixing is not sort of like, it's not to the optimal. They are like the optimal rate of mixing and so on. So that's why even for this, you see this thing, you see they are lorry also. They also have the what we call, they use this thing to mix. So mixing is very important when you want to prepare the material. The way how you mix, how fast you mix, how long you need to mix. In case of epoxy, premature mixing will cause the bubble like this, right? Will cause the bubble like that. So how to reduce the bubble? Here, if you see this thing, this is less viscous. Not as viscous as cement or silicone. Later on, you will see the silicone. So this thing, if you look now, the bubbles is already rise up. The bubble is already rise up, meaning that they are lesser bubble because it's less viscous. But most of the common epoxy, common silicone, common concrete, they are viscous. Just I want to show you how, if let's say you have something, I make it like this, like crazy like this now, and then you see there are a lot of bubble, right? So how to remove this bubble? Let's say in this cup is okay, you can just left it just like that. But if you have like a gallon, or I mean like a pool of this thing, then it's difficult, you know. Here cup, sometimes when you see like this, is in theory it's easy. You see, oh, the bubble is removed and so on. But when you go to industry, it's a different matter. You deal with the big thing. So normally when they do how they remove this is they use a vacuum lah. They use vacuum, the one that we learned before. Let me remove this zoom first. So basically what you do is that you take the vacuum we have learned before. You have this thing, you put inside this. Yeah, it's okay with the thing, and then you have put like that, and then I will sort of like zoom it later on. So what happened there when you do vacuum? So this vacuum, so let me do like this. I want to just show you there. So let me zoom there, zoom inside, zoom inside, zoom inside, zoom inside, zoom inside. So now you can see there are a lot of bubble there. Okay, now I open the vacuum. Let me close this thing first. Close the valve, open the vacuum. So you can see now. So look carefully on what happened to the bubble to this thing. Okay, I don't know whether it's sharp or not, but hopefully. Okay, later on, the bubble inside the epoxy will force to coming up, and then it will sort of like saturate the surface. Because remember, when you make vacuum, at the same time you induce the bubble, you create the bubble also. But now, as you can see now, no, it's not clear. I don't know whether it's clear or not, but hopefully it's clear. Later on, it's not clear lah. Let me zoom. It's not very clear. Let me focus. This is a problem when you let me let me focus there. Okay. Hopefully you can see lah. It just that's the best I can use with this thing. Hopefully you can see the thing. You see on the surface of the epoxy there are a lot of bubble happen because when you reduce the pressure, you also reduce the vapor pressure on top of the epoxy. So meaning that the molecule of the epoxy in the surface have more energy now to escape. That's why you see the bubble happening on the surface. So you might say, okay, now you are making things worse. There are more bubble there. But remember, all this bubble is on the surface. The problem now, when you make the epoxy, the bubble inside the mix. On the surface it's okay because it will easily pop later on. In fact, if I close this vacuum, the what we call the bubble on the surface will be self collapse. So now I close the vacuum, so you can see now there are a lot of bubble there. I'm sorry because the sharpness is not good, but if I close this, so you can see, so the thing become very clear now. So the epoxy, there are no bubble inside. So let's see, I put there and then I take this out because I want to show this thing. So that's enough. So that thing. So now you can see now. Yeah, there are no bubble inside. Okay, the darker thing that you can see now, that's not bubble. That's not bubble there. That is just the bottom of the cup. Okay, this is plastic cup. So there are no bubble compared to before. There are no bubble inside. So when you have this, when you cast, you have something that is bubble free cast. So now if I have something like this, so let me close. Penat nak buat macam ni. So let's say I do like this. Okay, so I have this thing and I want to cast something. So you just put lah whatever you want to put. Let's say I put daun ke, whatever, daun like this. And then I put like batu ke. Saya ada batu. So batu like this. And then I cast lah. Just casting is just simply you pour like this slowly. Because when you pour it very hard, if you just pour just in one go, then it will spill and so on. I just cast slowly and so on because just cast slowly like that, and blah 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 blah, and that's it. So now you already cast the resin. So now this is basically what you do lah, the cast resin, and at the end of the day you get something like this. So this done. This will take around, this resin will take around like 1 day lah to cure. Okay, as I said, if you have 3-1, it take longer time to cure. So this I just left somewhere lah. So at the end you get something like this lah. This already done lah. So basically you see it's hard. So, and because it's epoxy, you can just remove easily like this. So you have something like this. Okay, I also have something like this. So I make two. This one, the one that have a only two, what we call two down to leaf here, is I make it in such a way that the ratio is not correct. The ratio for here is basically 2:1. I'm using this thing, the one that I show you. This is 3:1 actually, but I'm using this as a 2:1, meaning that I put 2 part of the resin and 1 part of the hardener. This one I do it correctly. I put 3 part of the resin and 3 part of the resin and 1 part of the hardener. By looking here, you see that it's more or less is okay, is cure like that, right? But if you try to test the strength, you can see here, if I do like this, janganlah patah. You can see it will easily bend. It's not strong. Okay, even though it look solid, it's not as strong as the hard thing lah, because epoxy when it's cured fully, it become very hard lah, like this. This is very hard lah. It's really like a solid lah, like a metal lah, like solid. So that's a different. If you mix, ratio is very important when you mix the epoxy or any material. It's very important lah. And this thing now you have this thermoset thing. So this is thermoset lah. Whatever this thing, the keychain that you buy in when you go to visit somewhere, Cumberland Highland, whatever. The keychain is basically made from the epoxy lah. So this thing is thermoset, meaning that if you try to melt this, you cannot melt this thing. It will, you take the blowtorch or whatever heat, it will degrade, meaning that you cannot reuse again. You cannot melt this thing and then get again lah. So that is basically the what we call the epoxy lah. Okay, so that's the use of the term lah. So basically the remove the bubble here. So let me put here. Removing the bubble here. Removing the bubble here, the one that you see inside that thing, the one that I put like this, and then I put the vacuum here, and then I put the vacuum. So this is vacuum. The term for this is basically degassing. Degassing. In polymer field, this the jargon used here is degassing. Okay, for this is okay. You have something that is less viscous. Less viscous is easy. The bubble can go rise very easily. But we also learned about silicone right before. Just now we learned about the epoxy. You have also the liquid silicone. The silicone, you see something like this, right? This is silicone. Okay, this is silicone. Okay, silicone. And also when you go to DIY store, you can also see something like this. This thing. Okay, sometimes they call it silicone sealant, whatever thing. So inside this is like a paste. It's a paste. It's a paste. So for example, if I show here, so let me remove this thing first. Okay, so this is we do last week. Monday, last week we do in the lab. So basically what we did is that basically we try to use this to make the o-ring. Remember the properties of the silicone is it have this elastomeric properties, meaning that it can deform when you pull, so you can seal the crevice. So we want to make the o-ring. So remember, you see here the big stuff, the big container, the steel container here. I want to make the o-ring, okay, but I don't want to buy because it's expensive lah to custom made. But yeah, you can just buy this thing, the silicone. You have the silicone, right? You just cut so that you get something like this. You can also get something like this, but you need to buy the big one lah. And the silicone, if you buy like this, is expensive lah. Okay, so if you ask them to custom made like this, it's more expensive lah. For that big lah. Silicone is cheap, but then the labor to need is expensive. So now the idea is that I want to use the silicone inside this, and I want to create the o-ring like that. So basically we do whatever lah this thing. So basically this silicone, you can see the silicone is like a paste. Okay, this silicone, if you look here, if I don't know whether you can see here, this is basically RTV, room temperature vulcanization. You remember before, right? The rubber, the vulcanization. What does it mean by vulcanization? It's basically volcano, right? Volcano is heat. You need heat. Vulcanization, you need heat to sort of like to cross-link the sulfur in rubber lah. Remember last class This class is basically I just recap whatever you learned before lah. You use vulcanization. You use sulfur. You add sulfur. You put heat. Mix the rubber together, then you get this vulcanized rubber. Here, what does it mean by this is basically RTV acetic. I don't know whether it's RTV acetic. It's basically R. R is room. T is temperature. Room temperature vulcanization. And you have the acetic here, meaning that you have the acetic acid. Okay, acetic acid inside this thing. So, room temperature vulcanization, meaning that when you take it out this, okay, the acetic acid inside the silicone will sort of like react with the room, the moisture in the room, whatever, and then it will become hardened like this. It become hardened like this. Okay, basically this thing, the one that I do this thing is basically using this lah. This thing is colorless. I mean, I buy the colorless and then I put the food dye lah. Just use orange color food and then you get something like this lah. So it's just like that. So the silicone, over time, this is paste like that, the one that you see in front of you, and then over time it become sort of like elastomer like this. So this is how you make the silicone lah, silicone. So you get something like that. So this, so you can see we just use the color, this thing, whatever, blah blah blah, this thing, and then we make the O-ring like that. Okay, we make the O-ring like this. So just like that lah, make the O-ring for this thing. And then the reason why we make this O-ring is we want to make a vacuum chamber. Previously, I show you the vacuum chamber is useful to make the what we call the degas chamber lah, for the polymer making and so on. So this one way to make the vacuum chamber if you don't have money. You do that thing, you buy something in the what we call DIY shop, whatever, you make the O-ring and then you take any acrylic, any thick acrylic, put on top and then grind a hole and then you make the hose connect to the vacuum pump and then you get vacuum chamber. So that's the way how this thing. But this is the if you see, this is the paste silicone, the paste silicone. But if you see something like but the silicone also can come like this, can come like this in the liquid form. Okay, it can come in the liquid form. So for example, the one that the one like this, the one like this, this is the liquid silicone, liquid silicone. So when something in liquid, okay, normally they have two part. So this is the initiator. So you have two part, because if you have something in liquid and you want to make it hard, you need to cross-link it with something. This thing, it doesn't react with the moisture. You need to have this catalyst. So this I don't do lah, but I just to show you how it look like lah. So it's basically something like this lah, something like this. Yeah, it's liquid, right? It's liquid. It's like liquid. It's like a paint like that. And this basically, when you have something liquid, the advantage of having something liquid, regardless it's silicone or epoxy, is that you can mold it. You can put in any mold, and you can make the mold lah. For example, if people make this baby nipple, wait, this thing. Okay, you can see this is made from the silicone. Okay, so because it's so small, then the way how people do is to mold lah using the silicone. So they use this thing, liquid silicone. They don't use the paste silicone. If you have paste silicone, how do you want to do that? Okay, so you have the liquid make things easy to mold, because when you are working with polymer, at the end result is that you want to make something that have a certain shape, assume certain shape. So you want to mold it in certain shape. So the easiest way to get something turn into a certain shape is to put into mold. Like previously we put mold in this thing, right? This thing, we put mold in this thing, this silicone. In fact, this thing also is made by using this thing. The silicone that you see just now is made using this thing. This thing, okay? You cast lah, you cast whatever in the mold, and then you get something like this lah. So then you get something like this, and then you can make something hard using epoxy. Silicone is good if you want something pliable. Epoxy is good when you want to make something hard like that. Okay. So the advantage of the silicone, is that why people use silicone? We learn about epoxy. Epoxy you can hard. The silicone, advantage of the silicone is that silicone, the reason why people use silicone is that is durable. It's durable and highly resistant. Elastomer. Okay, the word elastomer, because if you want plastic that is resistant, then you can use a lot of plastic. HDPE, the one that you see, just this right, HDPE, made from the HDPE, it's also durable. It's strong, right? It's strong. But this not like rubber-like. You need something that, if you want something that is elastomer, something that is rubber-like, but it's more durable than rubber, then you use silicone. And also silicone also have high what we call they have this can withstand temperature from -50 to maybe 350 lah, 350 Celsius, meaning that you can use silicone, you can use this for making baking whatsoever. Some baking paper they coat with the silicone, okay. And you can also see most of the people who are doing a baking, they use a silicone mat put into the oven, because silicone can withstand the high temperature. Rubber you cannot lah. Rubber, if you have rubber, then gone lah. And also it have good weathability, meaning that it can resist ozone. If you have a rubber resist ozone, let me make it small here, you cannot see, right? When you have rubber, you put under the sun, over time you can see that rubber crack, right? Over time, the ozone from the sun, if you have rubber, the rubber will sort of like become hardened, and over time it will crack also. But silicone, one of the advantage of silicone, they have good weathability lah. And also it have this chemical stability. It's good in chemical stability, and also is biocompatible. That's why people make this silicone implant, right? People make what we call silicone implant, breast implant or whatsoever. They use silicone because it's also good biocompatible. That's also why people in the kitchen, many of them also use silicone in your kitchen lah. Okay. And also he have this electrical insulation, and also so that is basically the silicone. And also, as I said before, the type of the silicone that you can the color, wait, I put the color. So the silicone, you can have this RTV stand for room temperature vulcanization. Remember vulcanization in the previous class, we have talked about the vulcanization in the previous class. And it also have apa ni, silap. Okay, let me put like this. And then you have also here, you have this sometimes they call it STV. This is high temperature vulcanization. Normally STV, this thing I don't show you, but it's basically come in solid. Okay. RTV here normally in paste lah, in paste whatever lah, mean that it's easy for you to deal with it. Okay. HTV is basically they give you in the silicone block, okay, and then you need to sort of like do some processing, melting, extrude and so on, in order to get whatever you want lah. HTV, so basically it's high temperature vulcanization, meaning that you need the high temperature in order to cure this thing. You don't need temperature, you just do like that, and then over time, after 20 minutes, it will cure meaning that it become like this lah. HTV meaning that you need heat. And one more last thing, you have this what we call LSR lah. LSR is basically liquid silicone rubber. Okay, I think that's it for today. It's already 9:29. Okay, just a quick question time, because I think we will continue again. I think we still need to continue the polymer maybe next time, but let's do just a quick question time. This is just a quick question time. So question time now. Question time. Okay, question number 1. Question number 1. Tell me about vulcanized rubber. Okay, vulcanized rubber. Tell me about vulcanized rubber. Anyone? Vulcanized rubber. Sorry?
Speaker.
I know lah. I know. Okay, tell me.
The vulcanization of rubber is the adding of sulfur in the chain through high temperature.
Time and then.
It is formed through a very high temperature.
Okay, and then what happened? What happened when this happened? What happened during vulcanization?
The chain.
What the term? What happened during the vulcanization? What happened to the sulfur and the rubber molecule?
Vulcanization.
Yeah, what happened
The
during
term?
vulcanization? There are term for that. Start with the C and finish with the K.
Crosslink.
Yeah, crosslink. So that is the whenever you talk about this vulcanization or what we call epoxy, the term is crosslink. I mean the jargon is crosslink. Okay, question number 2. Question number 2. Tell me about how people recycle rubber. What does it mean by recycle? Shakila first. Shakila, tell me.
So recycle for rubber, there are two. Firstly, you can melt the product and by using heat, and the other way is by shadder.
Not shader. Shredded.
Shredded.
Basically rubber you cannot melt. I mean that this is basically when you want to talk about recycle, the term recycle, either you melt and then reuse, or you sort of like shred and reuse the same thing without melting. So that is generic term of recycle lah. So for rubber you can only do this thing lah. And Shakila, what normally people do for this?
The rubbing pavement.
Pavement. Okay, question number 3. Tell me about silicone.
Nisha, sir, Nisha.
Nisha.
Okay. Silicone, it is durable and highly resistant elastomer, and it is withstand temperature from 50 Celsius to 350 Celsius.
Okay.
And it is good weatherability, resist to ozone. And it is also chemical stability and biocompatible. It is also electrical insulation, and it has three different what we call RTV, HTV, and LSR. RTV stands for room temperature vulcanization. It is in the form of paste, and secondly HTV, which is we call it high temperature vulcanization. It is in solid. And the last one is liquid silicone rubber.
Okay, thank you, Akila. Okay, for one of the person in front of that open the camera, tell me about degassing. What does it mean by degassing? What does it mean by degassing?
Faiz.
Okay, Faiz. Tell me about Faiz. What is degassing? What is the purpose of degassing and how you do it?
Degassing is actually to remove the bubble inside something like when we combine the resin and hardener, it have a bubble inside, right? And then we use the vacuum to remove the bubble, and it called degassing.
Okay, thank you, Faiz. Okay, so that's it for today. We end our class with recitation of recitation of Tasbih Kafara and Suratul As.